Hello YouTube viewers, welcome to my channel Science to Technology. Today we're gonna have a very interesting discussion about power bricks or power supplies. Or basically this puppy which basically takes AC mains input, generally in my case 220 volts at 50 hertz, this puppy, and then it gives DC output. Now lot of laws have been passed regarding these things. What does that mean for you and me? So let's understand this. So you have to understand, in 1980s electronics became a thing. So a lot of things were made, and by 1990s there was the explosion of things, lot of things. So lot of adapters were also made to run those puppies. So you could have lot of 9 volt, lot of 12 volts, 7 volt, lot of other things. And in terms of jacks, people went bonkers with it, meaning I have modified this laptop jack to have common jacks, but they always have their own proprietary. And be mindful, it could change inside a brand. So Sony could literally have 5-6 jacks and all that. So it started to get out of hand. At early as 2005, European Union noticed that it was creating way too much e-waste, junkyards full of e-waste just with power bricks, because the devices were generally thrown out, because if you lost the power brick, how would you know? And if it's not a very high value item, you will just eat it, even though you could use it, and rather than buying something new unnecessarily, you could have used it. But because of power bricks, and generally because of so much random production, quality control on the power bricks was surprisingly low. You would think power bricks would be like very high quality, but no, it was not, because it was not getting enough research and development. There was no handshake, there was no standardization. Thankfully, you first passed a law that all smartphone, this is just before smartphone were becoming a thing, so they realized very early on, especially after the mess of feature set handsets, it's like, yeah, we're gonna need something better. So thankfully USB charging standard was passed, and the law was everybody has to use USB based chargings for all their smartphones. It worked except Apple found a loophole. Loophole was that if you have a quote-unquote small device, you have to use a adapter-based system. So they showed their iPhone. That's why if you buy iPhone, it has proprietary connector, lightning connector, or their old school connector. Why the heck they have USB on the other end? Yeah, it was to regulate that law. And why did Apple put so much money into it? Yeah, because Apple is a very poor company and they cannot be happy with $1 trillion. So they wanted that made for iPhone sticker. Yeah, so that sticker is very expensive. They make a lot of money. So thankfully EU learned the lesson, and there was a second problem. While all Android did agree to USB-C, they did create an issue. There was everybody made their own proprietary standard, meaning we were ironically back to this, where every company had their own. So you had VOOC charger, Samsung charger, Hulalala charger, Jingalala charger. I'm reasonably sure your household could at least have 2 or 3 different charging standards because of the fast hazard. Because USB-C was designed for 5 volts 1 amp or 5 volt 2 amps. Anything above required proprietary handshake. Now this time European Union learned their lesson. They literally took a missile, shove it up Apple's ass, and they're like, you will use USB-C. I do not care what, you will use it. So USB-C is now standard. On top of that, they took another missile, they fired it directly Android's ass. It's like, you all Android manufacturer, all Apple manufacturer, all of them must support, let me be very clear, must support PD standard or power delivery standard. 2024 is the last grace period year, meaning by 2025 all smartphones must support, let me be very clear, must support power delivery. They could have their own proprietary. So for example, a power delivery handshake till 60 watt, and if they require, let's say, 200 watts of charging on your smartphone, of course they could use something proprietary. But the core reason what they are removing is that while every Android charger did work with everyone, it was so slow, it was giving up an error message. You must have seen it sometimes, where it's like, charging rate is too slow, check the adapter and all that. No more that. You will have fast charging, of course not to the bonkers limit. As long as you are around 100 watt, you don't need anything fancy. If you crossing 100 watt, then yeah, then you may need your proprietary handshake. But again, more than enough people would be more than happy enough if power delivery even as low as 60 watt is supported. So here we come with this puppy. Now this is what you're supposed to have in your future, or right now you may already have this. This power brick came to me using my oscilloscope. So it has the same AC goes in, but instead of proprietary hoo-ha, it comes USB-C out. So we went from having weird voltage, where this example is 19.5 volt. Why? Because our development of electronic switching frequencies, meaning these puppies were barely touching kilohertz of frequency. Now we are touching megahertz of switching frequency. Now we can make it very small, and DC voltage up and down is super small. That's why it fits inside your mobile phone. That's why high voltage was used to charge your phone, because it can scale down it very effectively. So in PD, what does this mean? This simply means you buy a brick, the brick has a lot of voltage. It's not proprietary, it's open. So for example, this brick, this will give you 5 volts up to 3 amps, 9 volt, 3 amps, 12 volt, 3 amps, 15 volts, 3 amps, and 20 volts, 3.25 amps. Now, like, okay, what is this obsession with 3 amps? Yeah, there was a problem that Chinese manufacturers were cutting too much cost, and there was a risk if they allowed 5 amps, that will melt the cable and cause fire hazards. So they created a compromise. The compromise was till 3 amps, you should not have a melting cable unless you do way too cheap cost cutting, and it should be so cheap it will trigger alert in your mobile phone and smartphone instantaneously. So if you are cutting cost, you should be able to handle 3 amp. But if you need 5 amps, which is the full capacity of power delivery, yeah, you need a e-marker chip in the cable. Why e-marker chip? This is a protection mechanism where they're like, cable does a handshake. So your smartphone talks to the charger tells what are the voltage available I have. For example, if a smartphone talks to this, it can give it whatever voltage it requires, 15 volt, 12 volts and all that. You could have some power bricks that did not have 12 volts. So if a smartphone asks for 12 volt, it will not get 12 volt, it will downscale. So instead of downscaling to old school where it was like charging so slow, it will show an error. It will be like, okay, I don't have 12, let's use 9 volt. So same thing with power delivery. Lot of options, and you have enough up and down margin where almost everything should work. So you will have handshake for 5 amps. So 5 amp handshake requires a chip. That chip is so expensive that it would be equivalent of putting a like $1,000 chip on basically $1 cable. Yeah, you're not gonna do it, and not to mention people will find out very quickly at 5 amps. So it was a safety measure where they are making sure that under no circumstances you can get a 5 amp cable that is not rated to 5 amp. So this is today, but there is a new law that should be in implementation by 2026, 2 years from now. So as in, what would be our world like in January 2027? Well, we're gonna have something like this, bit bigger. So the reason it will be bigger, because it will have more amps, up to 5 amps. Like, wait a minute. It's the same as this. Yeah, but the voltage is upgraded. So this puppy will only go to 20 volt. I have no idea why not 24 volt, but okay. But if you increase the voltage, the jacks become the weakling. So if you plug it in your phone and the jack is not built properly, and so is the socket, yeah, you could have arcing issue and fire hazards. So for that reason, a new e-chip is created. Now this marker chip is for extended power range, EPR. And now that puppy will allow to do handshake, where it's like, okay, this chip is far more expensive, and you can only put it if you actually basically manage all the contacts for it. Basically your contacts have to be strong enough where it can withstand the corrosion and erosion of 48 volt. It's very high. So that's why it's not available yet. Only laptop that has introduced it right now, it's if I'm not mistaken, Framework, but it only goes to 36 volt. So if you want that full 200 watt power, 200 watt, you need 48 volt, 5 amps. The 5 amps is the limitation. They realize that if you want to carry more amps, the cable becomes ludicrously thick. So 5 amp it is, and because of improvements in buck boost converters, we can go all in with like switching it down. So your laptop battery does not need to be 48 volt. It can still be, let's say, 19 volts. It can easily scale it down without too much hassle. So that's future. So we started with here custom proprietary random voltage weird stuff. So right now we are at this stage where we have small efficient power brick which can work with lot of devices. And yes, this device does fast charge my mobile phone, which is very old, my mobile phone, mind you. And we can easily expect future mobile phone can still work with this, and actually it will give fast charging also, because again, my old smartphone does have the amp capacity, does not have the handshake capacity, and the law has been passed. So all new phones will support it. 2024 is the last year. Any phone that is made right now supports it without any issue. In future, all laptops, everything basically that is going up to 240 watts or 20 watts. So grace period is around 200 watts. If you have around 200 watts of load, you must use USB-C, must use power delivery. You can have your own proprietary on top of that, but that's not recommended. And this time EU is firing missiles directly at Apple and all other companies that are tricking it. It's like, no, you must support this. So in future, we're gonna have a world where you're gonna have a power brick that just works. Just works. The only issue it would be like, even if, let's say I'm using the 60 watt adapter with a laptop that is 200 watt, what will happen then? Well, here's the, if the computer is running on low power mode, it will just keep charging the battery. And if you close it and still keep it plugged in, it will trickle charge your battery. That's what we can achieve in the future. Basically, you will not be stuck anymore. and I'm very happy with this. So this was my interesting discussion about the Power Bricks, which I just found very interesting. Hopefully you guys have liked it, learned from it, what exactly it changes in your life. Hopefully you would have enjoyed this new standard style that I'm trying. In that case, please leave a comment. Hopefully I will see you guys in my next video. Bye.